I am Teacher Marian Biticar and I'll be your teacher in physical science. I hope you are all fit and fine. Are you now ready to our new lesson? At the end of the video lesson, you should be able to determine the limiting reactant in a reaction and calculate the amount of the product formed. Now, let's pretend that you're making a chocolate chip cookies. You want to make a full batch of 24. The recipe makes 24 cookies, but requires 2 cups of chocolate chips. You have enough of all other ingredients, but only have 1 cup of chocolate chips. Now, what ingredient is preventing you from making a full batch? Yes, you're right. It is the chocolate chips. How many will you make out of the ingredients? Okay, so you could make a batch with half the chips, but wouldn't be any good. The lack of chocolate chips is limiting you in making a full batch. So what do we call the chocolate chips? Yes, it is now the limiting factor. World, you have exactly as much of each reactant that you need to convert everything into a product. However, in real life, it is much more likely that you have a non-stoichiometric amount of reactants. The relative amount of the reactants and the products represented in a balanced chemical equation are often referred to as stoichiometric amount. Consider another food analogy. Making grilled cheese sandwich. We have 1 slice of cheese, 2 slices of bread, then we have 1 sandwich. Provided with 20 slices of bread and 11 slices of cheese, what is the greatest number of sandwich that we can make? Yes, you are right, 11. So what is the first ingredient that is used up? Yes, we ran out of cheese and we cannot make any more a sandwich. If this is the chemical reaction, what do you call the cheese? Yes, it is the limiting reactant. And what is limiting reactant? Limiting reactant, it is the first reactant that is used up in a chemical reaction. When the limiting reactant is all used up, no more product can form and the reaction stops. The total amount of sandwich that we can make is completely dependent on the number of cheese, the limiting reactant that we have. After we run out of cheese, we have some extra ingredients left. So what do you call the remaining bread left? The reactant in a chemical reaction that remains when a reaction stops when the limiting reactant is completely consumed. The excess reactant remains because there is nothing with which it can be reacted. In chemistry, just like in real life, there are rarely exact amounts of substances undergoing chemical reactions. There is usually too much of one reactant and not enough of another. The reactant that is used up first and so no more product can be made is the limiting reactant. The substance that is left is what we call the excess reactant. To find the limiting reactant, we need to calculate and compare the amount of the product of each reactant that will produce. And we have to follow the following step. First, we have to balance the chemical equation for the chemical reaction. Second, we have to convert the given information into moles. Third, we have to use the stoichiometry for each individual reactant to find the mass of the product produced. Fourth, the reactant that produces a lesser amount of the product is the limiting reactant. And the fifth one, the reactant that produces a larger amount of product is the excess reactant. Sample problem number 1. Calculate the mass of magnesium oxide possible if 2.40 grams of magnesium reacts with 10 grams of oxygen. What is the limiting reactant? Solution. First, we have to balance the equation. We have the magnesium and oxygen as the reactant, and the product is magnesium oxide. Okay, so let's count the number of atoms of each element. First, we have the magnesium. The number of atoms is only 1, while the product is only 1. This is balance. While the oxygen reactant number of atoms is 2, while the product is only 1, this is not balance. So let's put the coefficient 2 in the magnesium oxide. Okay, so this time there are 2 atoms of oxygen for the product, which is equal to the number of atoms of oxygen in the reactant, 2. Okay, balance. While the magnesium in the reactant is only 1, while the product is 2, it is not balanced. So let's put the coefficient 2 in the reactant magnesium. Okay, so we have now 2 atoms of magnesium for the reactant, and there is also 2 atoms of magnesium for the product. This is now balanced. We have now a balanced chemical equation. So we can proceed to step number 2 and 3. Converting mass to moles in stoichiometry. Okay, so we have 2.40 grams of magnesium times 1 mole of magnesium divided by the 24.31 grams of magnesium. This is the atomic weight of magnesium and can be found in the periodic table. Times 2 mole of magnesium oxide. It is in our balance chemical equation. 2 mole of magnesium oxide divided by 2 mole of magnesium, also in our balanced chemical equation, times 40.31 grams of magnesium oxide divided by 1 mole of magnesium oxide. So the 40.31 grams of magnesium oxide, this is the formula weight of the magnesium oxide. Okay, so how to get the formula weight of magnesium oxide? Okay, so let's count the number of atoms. Okay, so magnesium and oxygen, 1, 1. So magnesium, the atomic weight is 24.31, while the oxygen is 16. Okay, so add this, 40.31. Let's cancel now the unnecessary unit to remain the unit desired. We have the grams of magnesium, cancel the grams of magnesium, mole of magnesium cancel, mole of magnesium oxide cancel. We have grams of magnesium oxide. Let's solve. 2.40 times 1 divided by 24.31 times 2 divided by 2 times 40.31 divided by 1 equals 3.98 grams of magnesium oxide. Next, we have 10 grams of oxygen times 1 mole of oxygen. Okay, so this is found in the reactant. We have 1 mole of oxygen divided by 32 grams of oxygen. The 32 grams of oxygen, this is the atomic weight of the oxygen. We have 16 times 2. Okay, equals 32. 2 moles of magnesium oxide, it is found in the balanced chemical equation that we have 2 mole of magnesium oxide divided by 1 mole of oxygen times 40.31 grams of magnesium oxide. This is the formula weight of magnesium oxide divided by 1 mole of magnesium oxide. Okay, so now let's cancel the unnecessary units to remain the units desired. Okay, so cancel the grams of oxygen, mole of oxygen, mole of magnesium oxide, Okay, so we have the unit grams of magnesium oxide. Okay, so let's solve. 10 times 1 divided by 32 times 2 divided by 1 times 40.31 divided by 1 equals 25.2 grams of magnesium oxide. For step number 4, the reactant now that produces a smaller amount of the product is the limiting reactant. So magnesium produces less magnesium oxide than does of the oxygen. Therefore, the magnesium is the limiting reactant in this reaction. Step number 5, the reactant that produces a larger amount of product is the excess reactant. Oxygen produces more amount of magnesium oxide than magnesium. Therefore, oxygen is the excess reactant in this reaction. Sample problem number 2. What is the limiting reactant if 76.4 grams of vinyl bromide were reacted with 49.1 grams of oxygen? Okay, so we have solution. Let's balance the equation. So we have the reactant, vinyl bromide, and then the oxygen, the product is carbon dioxide, water, and bromine. Okay, so let's count the number of atoms of each element. Okay, so carbon, we only have 2 atoms of carbon here in the reactant, while in the product, carbon is 1. It is not balanced. Okay, so let's say for example, let's put here 4. Okay, and then so 4 times 2 is 8. So there are 8 atoms of carbon for the reactant. Okay, so for the product, let's put a coefficient 8 to make it 8 atoms of carbon. Okay, it is now balanced. Hydrogen. Hydrogen, we have 4 times 3 is 12. Okay, 12 atoms of hydrogen for the reactant, while the product, we only have 2. So to make this 12, let's put the coefficient 6. So 6 times 2, 12. Okay, so it is now balanced. Bromine. Okay, so for the bromine, we have 4 times 3, 12. For the reactant, 12 the product is only 2. To make this 12, let's put the coefficient 6, 12. Okay, so it is now balanced. Okay, so oxygen, we have here oxygen. Okay, so for the reactant, we only have 2 atoms of oxygen, while the product, okay, so let's count. 8 times 2, we have 16. Okay, plus, this is 6. 16 plus 6 is 22. There are 22 atoms of oxygen in the product, while in the reactant, there is only 11. To make this 22, we have to place here a coefficient 11. To make it 22. 11 times 2, 22. So, we have now a balanced chemical equation. Let's proceed to step 2 and 3. Converting mass to moles and stoichiometry. Okay. 76.4 grams of vinyl bromide times 1 mole of vinyl bromide is equal to 266.72 grams vinyl bromide. Okay, so how to get thus 266.72? Okay, so this is the formula weight of vinyl bromide. Okay, so how to get the formula weight of vinyl bromide? Okay, so we have 2 atoms of carbon, 3 atoms of hydrogen, and 3 atoms of bromine. Okay, so let's put here the number of atoms, and then we have the atomic number. It is found in the periodic table. So for the carbon, there are 12.01, hydrogen 1.00, while the bromine 79.90. Okay, so 2 times 12.01, 24.02. 3 times 1 is 3. 3 times 79.90 is 239.7. Total of 266.72 grams. Okay, so this one, 266.72 grams of vinyl bromide. Okay, and then times 8 mole of carbon dioxide. It is in the balanced chemical equation. We have here 8. Okay, so while the mole of the vinyl bromide is only 4. Okay, this one. Okay, so times 44.01 grams of carbon dioxide. Okay, so how to get the 44.01? That is the formula weight of carbon dioxide. Carbon dioxide is CO2. 1 atom of carbon, 2 atoms of oxygen. Okay, so 1 times 12 and then 2 times 30, 2 times 16. 16 is the atomic weight of oxygen. 2 times 16 is 32. So 12.01 plus 32 is equal to 44.01. Okay, so this is the formula weight of carbon dioxide. Okay, so now let's cancel the unnecessary units. Okay, so cancel the grams of vinyl bromide. Cancel the grams of vinyl bromide. Okay, cancel the mole of vinyl bromide. Cancel the mole of vinyl bromide. Okay, cancel the mole of carbon dioxide. Cancel the mole of carbon dioxide. Okay, so we have grams of carbon dioxide. Okay, so let's solve. 4 or 76.4 times 1 divided by 266.72 times 8 divided by 4 times 44.01 divided by 1 is equal to 25.2 grams carbon dioxide. Okay, next. Okay, so we have 49.1 grams of oxygen. Okay, so oxygen times 1 mole of oxygen divided by 32 grams of oxygen. So 32, 2 atoms of oxygen. So 16 times 2 is 32. Okay, so this is the 16 is the atomic number of or atomic weight of oxygen times 2 since 2 atoms of oxygen, 32 grams. Times 8 mole of carbon dioxide. It is here in our balanced chemical equation. Okay, divided by 11 moles of oxygen. Okay, so 11 moles, it is given in our balanced equation. Okay, times 44.01 grams of carbon dioxide. Okay, so 44 is the formula weight of carbon dioxide. Okay, formula weight of carbon dioxide. 44.01 grams of carbon dioxide divided by 1 mole of carbon dioxide is equal to 49.1 grams of carbon dioxide. So therefore, the vinyl bromide is the limiting reactant because you only have 25.02 or 25.2 grams of carbon dioxide. Unlike the oxygen, it has 49.1 grams of carbon dioxide. Sample problem number 3. 2 grams sample of ammonia is mixed with 4 grams of oxygen, which is the limiting reactant. Okay, so let's have our solution. So let's balance the equation. We have ammonia and oxygen for the reactant, nitrogen oxide and water for the product. Okay, so the nitrogen 1, nitrogen 1, balance. Hydrogen 3, hydrogen 2, it is not balanced. So let's say, for example, we will put here 4. 4 times 3, 12. Okay, so how about in the product? We have hydrogen is 2. And then let's put here 6 to make it 12. Okay, so 12, 12 balance. Oxygen. Oxygen reactant is 2. While in our product, so we have 4. Okay, 4 and then we have 6, 10. 10. Okay, so 10 atoms of oxygen here. So let's put as coefficient 5 in the reactant. Okay, 5 times 2, 10. So it is now balanced. Let's proceed to step 2 and 3, converting mass to moles and stoichiometry. Okay, so 2 grams of ammonia times 3 mole of ammonia divided by 17 grams of ammonia. So 17, this is the formula weight of ammonia. Okay, ammonia, we have 1, hydrogen 3. So 14 times, or 14 plus 3 is equal to 17. Okay, so times 4 mole of nitrogen oxide divided by 4 mole of ammonia times 30 grams of nitrogen oxide divided by 1 mole of nitrogen oxide. Okay, so let's solve. Okay, 2 times 1 divided by 1, or 17 I mean, times 4 divided by 4 times 30 divided by 1. Okay, so the answer is 3.53 grams. Okay, so let's cancel the unnecessary units. We have grams, cancel grams of ammonia, mole of ammonia, mole of ammonia. Okay, mole of nitrogen oxide, and mole of nitrogen oxide. To remain, the unit research is the grams of nitrogen oxide. Okay, next we have 4 grams of oxygen times 1 mole of oxygen. Okay, divided by 32 grams of oxygen. So 32 is because 16 times 2 is 32, 2 atoms of oxygen. Okay, times 4 mole of nitrogen oxide divided by 5 mole of oxygen. Okay, so times 30 grams of nitrogen oxide divided by 1 mole of nitrogen oxide. Okay, so cancel the unnecessary units. Okay, so we have the grams of oxygen, mole of oxygen, mole of oxygen, mole of nitrogen oxide, mole of nitrogen oxide. Okay, so the unit remain is 9. Okay, so grams of nitrogen oxide. Okay. Okay, so we have 4 times 1 divided by 32 times 4 divided by 5 times 30 divided by 1 equals 3 grams of nitrogen oxide. Thus, oxygen gas is the limiting reactant. This time, let's have an activity. You will answer an activity sheet that is sent to you. After you answer it, you will send it back to me for checking. Next meeting, we will answer those questions in your activity sheets to find out if you really understand our lesson. I hope you understand our lesson for today. See you next meeting for the continuation of our lesson. Bye and have a nice day!